Hey, sixth graders. Today we are going to be doing a video on what we've been learning in class to help those of you who feel like you're falling a little bit behind or who are having some trouble remembering how we put everything together. One of the most things that I want you to remember about ratios, but especially rates and unit rates, is that I do not want to just know that you know how to do division. Y'all have been doing division for years. The whole purpose of this entire unit is for me to see that you understand what a proportion is, what equivalent ratios and rates are, and how you solve for different things using those in the format of a proportion. So please help me with that and don't just try to solve the problems doing long division. Without further ado, let's go. The first thing I want to go over with you are 4 needed vocabulary words that you're going to have to be familiar with. The first is ratio. A ratio is a comparison of 2 different things or quantities. I should have put in another parenthesis there, that otherwise have no relationship or they're totally unrelated, and we compare these by division. An example would be pizza and kids. In real life, one is a food, one is a human being. They don't have any correlation to each other. But with ratios in math, we are able to compare these 2 objects and items together. An equivalent ratio is just like what we did with fractions. They are 2 ratios that name the exact same comparison. One is equal to the other. And we either use multiplication to make it bigger, or we use division to make it smaller. The last 2 vocabulary words that I want you to be familiar with is a rate. A rate is a special type of ratio that still shows the comparison of 2 things, but rates usually involve an element of either time or money. And these are 2 things that you've got to remember. When putting together proportions and rates, money always goes on top. Time always goes on bottom. The last vocabulary word is a unit rate, and that is a rate simplified down to where the bottom value is always 1, because unit actually means 1. Okay, we're diving right in, guys. We learned that there are 3 different ways to write a ratio. The first is called fraction form, and that's because we use a fraction bar. An example here would be 3 cats to 5 dogs. Or if you were just given numbers, it could be 3 to 5. Symbol form is the next way to write a ratio, and that uses a colon. It's a symbol that's 2 dots right above each other. So an example of this would be 3 cats to 5 dogs, or 3 to 5. The last one is word form, and that is where we actually use the word to, T-O. And for that, you're going to see we actually use that word, 3 cats to 5 dogs, or 3 to 5. And one thing I want you to remember is that you always put your items in the order that they've been given to you. There's not only 3 ways to write a ratio, there are 3 ways to solve a ratio. We can have a part to part, which would be like the 3 cats to the 5 dogs. We could have a part to a whole, which is like saying 5 dogs to 8 animals altogether, because 3 plus 5 equals 8. Or a whole to a part, which would be like 8 animals to 3 cats. These are all the different ways that we have to compare ratios. Now let's put that into practice. If you're given these pictures and you're asked, what is the ratio of hearts to diamonds? You're asked for hearts first, so you need to count the hearts. 2, 4, 6, 8, 10, 12, 14. So we have 14 hearts to how many diamonds? Well, 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4 is 28. That is the ratio of hearts to diamonds. Now it asks us, what is the ratio of triangles, oh, that's the wrong problem, of diamonds to both hearts and diamonds together? Guys, that is a whole. So right here, we know that we have 28 diamonds. The entire number would be where we have to add 14 plus 28, and we get 42. The next example, what is the ratio to triangles to diamonds? So how many triangles do we have? 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6, 7, 8. 6 times 8 is 48. How many diamonds do we have? 1, 2, 3, 4, 5, 6, 7, 8 to 1, 2, 3, 4, 5. 8 times 5 is 40. Now it asks, what is the ratio of diamonds to the triangles plus the diamonds? So again, that is a whole. We already know that we have 40 squares. Those are diamonds, sorry. And we're going to add those two together, and that equals 88 total parts. So that's why I wanted you to see whatever they ask for first goes first. And all four of these ratios were written in symbol form because they used a colon to separate the numbers. Okay, now let's write these two ratios in all three forms. Remember, we have fraction form, symbol form, and word form. 21 quarts to 84 quarts. As a fraction, they've been giving us 21 first, so that would be on top over 84. With a colon in symbol form, we would write it 21 to 84, and in word form, it would be 21 to 84. 24 beetles out of 36 insects. That is a part to a whole. This one was part to part. But let's do this one. They asked for beetles first, so we're going to say 24 over 36. As symbol form, it will be 24 to 36. And as word form, 24 to 36. Those are the ways that we write ratios in all three ways. These are the other two things that you're going to have to do. You're going to have to complete ratio tables to see if they are equivalent or to find equivalencies, and also solve to see if ratios are equal. And what we did in class is I told you on this first column, multiply these numbers by 2, and in the second column, multiply them times 3. But remember, I told you, they always go back to the original ratio. So if we wanted to find equivalent ratios to 7 over 8, 7 times 2 would be 14, 8 times 2 would be 16. Now we have to go back to the 7 to triple it. 7 times 3 is 21, and 8 times 3 is 24. Again, we're going to multiply times 2 to double it, and times 3 to triple it. 7 times 2 again is 14. 10 times 2 is 20. 7 times 3 is 21, and 10 times 3 is 30. So that is how you would fill in tables if you're trying to find equivalencies. Now let's look and see if these are equivalent. These are going to be yes, no answers. Let's look at 5, and what do we have to do to 5 to make it become 10? We have to multiply it by 2. The only way these can be equivalent is if the bottom was equal to multiplying times 2 as well. Well, does 2 times 2 equal 11? Nope. So our answer here would be no, they're not equivalent. Now let's look at this one. 3 to 3. I'm multiplying times 1. Am I multiplying the top times 1? Again, no. The only way they could be equivalent is if you did the same thing to the top and to the bottom. And the last thing you're going to need to know to do with ratios is how to solve for the unknown. This is something you guys have not seen before until now, where we use a letter in place of where the unknown is. And that just means that that letter can stand for a specific number that you find. We have to find out what the value of R and Y are. We want these two to be equivalent ratios to each other. And since we have two bottom numbers and the blank is on the left, I have to start at the right and work to the left and do the same thing to the top. To go from 10 to 60, I multiply times 6. So I do the same thing to the top, and 11 times 6 is 66. Here, we're going to go left to right because I have the two denominators or the two bottom numbers, but my unknown is on the right, so I have to work from left to right. 12 goes into 48 4 times, so I'm going to multiply times 4. I do the same thing to the top, and so 5 times 4 is 20. Okay, the next thing that we're going to do is shift from looking at ratios to rates. Again, I want to remind you what we talked about with our vocabulary. Money always goes on top, time always goes on bottom, and if none of these are given to you in the problem, the first quantity is on top and the second quantity is on bottom. Let's write these rates. The first one they give us is 6 calculators cost $160. Well, if we say money goes on top, we're going to put $160 on top over 6 calculators. When you're dealing with rates and proportions, it is so important that you label all of your answers. The next one is 90 miles on 6 gallons of gas. That's like what your car could drive. Do we have time or money? Nope. So we have to write 90 miles on top and 6 gallons on bottom. Then last but not least, we do have time. We have hours. 12 inches of snow in 9 hours. So since time goes on bottom, we're going to put 12 inches on top and 9 hours on bottom. Now this is where we're going to have a little bit of time to solve for what we call a unit rate. I'm going to pause right there, and our next video will be how do you solve for a unit rate. Thanks, guys.